HackerOne is your big opportunity. Whether you are a bug hunter, ethical hacker, or penetration tester, this is a place for you because you can go there and you can hack legally. And at the same time, you can make money, which is just beautiful. You can get different rewards for your hacking. For example, you can get $100, $1,000, or even $10,000 per bug. It's just awesome. What you need is an internet connection and knowledge. You can hack many different companies that are clients of HackerOne. For example, Twitter, Yahoo, Uber, Coinbase, and a lot more. Can you see that? The biggest companies in the world are clients of HackerOne. And now you can go there and you can hack them legally and make money. It's like a dream, but it really works. I will tell you even more. Even the United States Department of Defense is a client of HackerOne. So now even the government organizations are out there for you and you can hack them and you can do it legally. It's just beautiful. I am really excited about it. Now the question is what you can hack at HackerOne. Well, you can hack all the things. You can hack web apps. You can hack mobile apps, desktop apps, even network infrastructures. It's amazing. It depends on the program, of course, but you see a lot of different options. In this course, I will focus on the web apps because this is the most popular target at HackerOne, right? Virtually every single company has web application and web service that is in scope of their program so that you can go there, you can hack and make money at the same time, right? That's what I'm gonna focus on, web apps, because they are the most popular target at HackerOne. But don't worry if you specialize in mobile apps, desktop apps, or for example, network infrastructure hacking. You can still find a lot of opportunities out there. Now the question is, well, you can say, David, it sounds really cool, but how shall I start? I already prepared a course, Start Hacking and Making Money Today at HackerOne. This is one of my previous courses. And in this course, I gave an introduction into the HackerOne and I presented the list of 5 bugs that I recommend you to start with. I just wanted to give you a kind of a starter, the bugs that really work. I am one of the top hackers at HackerOne and I'm really fortunate to be on this list. And I just wanted to share with you what works, what kind of bugs I submitted for years as a starter and how I got different rewards. Now we have to realize that, well, we've got a lot more than 5 bugs, right? For a start. That's why we need something extra. We need more bugs because we want to double our rewards. We want to double our payments, right? So now it's time for a follow-up course. And this is exactly what this course is all about. I'm going to give you more knowledge. I'm going to give you more bugs because I want you to progress. I want you to hack and make money. So what I'm going to present is the next 5 bugs. Yeah, more bugs for you so that you can be more and more successful. And this course is going to be technical. So I will dive into demos. I love demos because in the demos you can see how things really work. Because I want you to reproduce all these bugs in your own pen testing, in your own hacking, right? If you don't see this kind of hands-on stuff, you cannot reproduce the steps. So I will dive into the demos. Of course, there will be some kind of overview at the beginning, but then we will jump directly to the demos because I want you at the very end of this course to be able to find more and more bugs in your own hacking. So let me now jump to the next 5 bugs. The first one is related to login functionality. I'm going to show you how you can impersonate a user when there is a kind of problem in login functionality. is going to be related to broken session management. And I see this kind of problem quite often. That's why I'm going to present it to you, because quite often you can get paid for this kind of problem. Next, I'm going to dive to something very different. I'm going to dive into the metadata. Bug hunters very rarely look into the metadata, but this is an opportunity for you. You can find a lot of sensitive information in metadata. Metadata is something that you don't see, but it is out there and it can contain some sensitive information, right? This is how it works. I'm going to show you step by step how you can extract this metadata and learn if there is any kind of information disclosure. After that, I will discuss disclosure of credentials, and I'm going to show you how you can find the disclosure of credentials in a web application. So you will be playing with HTTPS enforcement, and you will see how it works, if there is any kind of problem in the web app or not. After that, I will discuss insecure password change. Password change obviously is a very sensitive functionality, and we want everything to be implemented securely out there. But in reality, there are different problems, and I'm going to show you one interesting problem that I find quite often in different web apps. So it will be the bug number 4 in this course. And finally, I will discuss a dictionary attack. So I'll tell you what it is actually and how to find whether this attack is possible, so that you will be really able to check this out on your own. So basically, this is it. The next 5 bugs that really work for me, that I have been submitting for years to different companies, and I got paid for these bugs. And I want you to be more and more successful as a hacker. HackerOne is a really great opportunity right now for us bug hunters, ethical hackers, penetration testers. So I hope you will make the most of this course, you will enjoy the course, and at the very end, you will make more money. So this is it for an introduction. So now let's jump to the next video. And the next video actually is gonna be the first bug from this list.
To impersonate a user via insecure login. In this video, I'm going to show you what kind of severe consequences can happen at the intersection of login functionality and insecure session management. So let me first discuss a story so that you've got an understanding of the problem. Let's assume that the user is logged out and the session ID of the user, in short SID, is ABC, just for the simplicity. And this is a non-authenticated session ID because the user is logged out. Okay? Next, the attacker comes in and the attacker learns a user's session ID. Well, it is useless at this moment because the user is logged out. So the attacker cannot do anything with this information. But let's carry on our story and you will see what interesting can happen later on. So next, the user logs in to the web application and the user provides, for example, email and password. And after that, the user is authenticated and the user is recognized by session ID. And this is authenticated session ID at this time, right? So the user has been authenticated after providing email and password. And now the only piece of data that is used by the web application to recognize the user is the session ID. This is how web application works. Now we are talking about authenticated session ID because the user is authenticated. So far, so good. Now let's assume that the session ID, in short SID, has not been regenerated at the time of authentication. In other words, it has still the same value. So let's assume that the value of SID is still ABC. Now we've got something very interesting from the attacker's point of view, because now the attacker can impersonate a user. Because look at that, at this moment, non-authenticated session ID is equal to authenticated session ID. They are the same. We've got still the same SID. So at the very beginning of the story, when the user was logged out, the session ID that the attacker was able to learn was useless because the user was logged out. But now the user is logged in using the same value of session ID, so now this is no longer useless to the attacker. Now the attacker can use this session ID to get access to the user's account because, as I told you, once the user is successfully authenticated, then the only piece of data that is used by the web application to recognize the user is session ID. Can you see that? It's beautiful. This kind of intersection of very sensitive functionality like login and broken session management. And you see that it can lead to very severe consequences. Now I believe that you understand what is going on in the story. So I'm going to jump right now to the demo because I can't wait to present it to you in practice, how you can, actually see if this kind of problem happens in the web application or not. So let's jump to the demo. I'm gonna show you how you can impersonate a user via insecure login. In other words, I'm gonna show you how you can find out whether this kind of attack is possible in your web application. As you can see, right now I am logged out. So let me first check my non-authenticated session ID. For this purpose, I will use Cookies Manager because Cookies Manager allows me easily to play with the cookies in the web application. Here is my session ID. The name of the cookie with session ID is PHP SesID. My web application is hosted on the domain example.com. And here is the value of my session ID. And to be more precise, this is the value of non-authenticated session ID because right now I am logged out. Okay, let me copy the value of this non-authenticated session ID. So I'll copy it. I'll close Cookies Manager. And I will paste this value here in the document. And I will put some comment like this is non-authenticated session ID. Okay, so far so good. What I'm going to do in a minute is I'm going to provide in the very same document also the value of authenticated session ID and I'm going to compare them, right? So now let me go back to my web application and let me log in. So I will provide my email and my password and I will click login. As you can see in the upper right corner, there is my name, David, and it suggests that I am indeed authenticated right now. I will click it so that you can see my profile now. No doubts, I am really authenticated. Okay, so I have been authenticated. So in terms of session management, in terms of session ID, right now we are talking about authenticated session ID, right? So let me go again to Cookies Manager. And let me copy the value of my session ID. Right now, I'm authenticated, so we are talking about authenticated session ID. I'm gonna copy this value and I'm gonna paste this value to my file. And I will put a comment that this is authenticated session ID. Now, let's make a short comparison. As you can see, the values of non-authenticated session ID and authenticated session ID are the same. In other words, the session ID has not been regenerated at the time of authentication, which is really great from the attacker's point of view. Because as I explained to you in the previous video, the attacker can learn the non-authenticated session ID of the user when the user is logged out. At that time, it is useless piece of information for the attacker. But then the user comes in, the user provides email password, the user becomes authenticated. And once the user is authenticated, then the only piece of data that is used by the web application to recognize the user is a session ID. And if the session ID, authenticated session ID, is the same as the non-authenticated session ID at the very beginning, before logging in, then you will end up in problem, because then the attacker can get access to your account without knowing your email and password. Can you see that? Can you see how beautiful it is from the attacker's point of view? The attacker does not have to know your login and password in order to get access to your account. And now you see how powerful it is to do security testing of session management. In other words, broken session management can lead to very severe consequences. So now I believe that it is clear, and you see that you can do this kind of testing very quickly, and I believe that you understand all the steps. So I hope it has been informative for you, and let me jump to the next bug on our list. Let me now discuss sensitive information in metadata. Metadata is really interesting from the attacker's point of view. Metadata is a very nice creature, let's say, because you don't see it. Metadata is hidden. That's the nature of metadata. But you can find it in the document. So it's beautiful. You don't see it, but you can find it. Now, just to give you a better understanding of metadata, what it actually is, so you've got a kind of real life imagination of metadata, think about tracking changes. When you've got a Microsoft Word document, there is something like tracking changes, very popular. And if you don't delete the tracking changes before publishing the document, well, the tracking changes may be hidden, but it is still out there, and you can find some very nice, interesting, sensitive information in the comments, right? This is just an example, just to give you a kind of a feeling of what the metadata is, a real-world example, let's say. Okay, so you can really find sensitive information in metadata, for example, passwords. Yes, you can find passwords. And this is exactly what I will show you in a demo in a minute, but there might be a lot of different, interesting information. Just imagine different kind of comments, right? In comments, you can see, well, a plethora of interesting information. Passwords is just an example, but very nice example if you can fetch some credentials, right, from the metadata. Now, the question is how you can actually find the metadata in doc files, docx, PDF, and a lot of different file formats. Because, well, the point is that you can find metadata in many different files, but, well, the most popular ones are like docx, PDF, and stuff like that. There is a tool called EXIF tool, and this tool can be used to extract the metadata from a given file. And when you do this, then you just have to go through this metadata and find out whether there is something interesting. That's it. And you can use this tool very easily. Well, of course, you need to install this tool, and then you have to type something like exif tool -a and name of the file, for example, abcd.doc. And that's it. Then you just need to read what has been retrieved by this tool, and well, you have to make a kind of judgment whether there is something sensitive or not. That's it. So no need to talk more about this. Let's jump to the demo and let me show you how it works in practice. How to extract the metadata from files that are hosted on the domain that you are testing, right? So if your web application is hosted on the domain, for example, example.com, like what I have in my testing web application, then I am interested in all files that are hosted on this domain, in different doc files, docx files, PDFs, and stuff like that. Why am I interested in this? Because, this is an integral part of the web application, and it may happen that I will find some sensitive, interesting information in the metadata of these documents. That's why this is something really interesting from my point of view, and also from the attacker's point of view, right? Because the attacker is interested in the disclosure of sensitive data. Okay, so what I've got here is the cookie policy, and maybe you can see it in the bottom left corner. This is a doc file, cookiepolicy.doc. Let me now click right and save it on my disk, and now you clearly see that this is cookiepolicy.doc, right? And let me save it. So I'm gonna save it in cookie policy directory. Okay, now it has been saved. So it has been saved on my disk, and now I'm gonna go to the command line, and well, it has been saved on desktop in cookie policy directory, so it is out there. Let me show you that indeed it is here. Yes, cookiepolicy.doc. So now I'm gonna use EXIF tool in order to retrieve the metadata from this file. So let me do it. So EXIF tool -a and the name of the file. Very simple command. But before I click this command, I'm gonna show you how this file looks like, because I want to show you that at the first glance you don't see the metadata, but when you launch this command, when you use EXIF tool, you can see what is hidden actually out there. Okay, so let me first go to cookie policy directory. I will click it, and what I've got here is just a cookie policy. Look at that. Well, cookie policy we may use now or in the future, cookies on the site, stuff like that. Just go through it. Nothing interesting, right? Nothing sensitive out there. Just a kind of a text, right? We've got just a text. Nothing sensitive out there. But as I told you, metadata is hidden. You don't see it, but you can find it in the document, and for that reason we can use EXIF tool, because this is really the fast way of retrieving the metadata. So let me now go back to my command line. Let me now hit enter, and voila, you see the metadata extracted. You see different kind of information, like here you've got file modification time and stuff like that. And you can go for this kind of metadata, but there is something really interesting in the comments here, right? Read this stuff, and especially the second line. Let me highlight it right now. So Ben, please review this document and then upload it to the following directory, and this is the directory: ftp://root: super secure password at 192.168 and more, right? This is it. Here you see something very nice. What you've got after the protocol part, so ftp:// are the credentials to the FTP. This is how you can actually provide credentials to the FTP. After // you can provide the credentials. So root is the login, and super secure password is the password. This is very nice. This is a kind of metadata that has been extracted. You didn't see it when I presented this file to you, but you clearly see that it is somewhere there inside, hidden. And this is it. This is the power of metadata extraction. And I really recommend you to also, in your own pen testing hacking, go around and fetch the metadata, because you can find quite many interesting information out there. Because, there are different people that cooperate in a given company, and before publishing the documents, they forget to delete the metadata from a given file. People just put the links, like here, the links with credentials right inside. When something like this is somewhere in the file and you can fetch it from the file, then you immediately know the credentials, right? So this is beautiful from the attacker's point of view. This is a kind of interesting bug that you can find, and you can get paid for it, because here we are talking about sensitive data exposure, right? Or disclosure of sensitive data. I hope it is clear. You see how easily you can use EXIF tool to fetch the metadata. You can do it quickly, and you can find some interesting stuff inside the documents. So I believe that this is clear, and let me now jump to another bug on our list. Disclosure of credentials. This is what I'm going to discuss right now this is the bug number 3 on our list. So I'm going to focus on login functionality because obviously when I talk about disclosure of credentials, then login functionality is a natural place to start looking around, right? So let's assume that we're gonna log in, and this is the URL related to our login functionality. https://example.com/login.php. So when you go to this URL, you are asked to provide your email and password. This URL looks good because we've got HTTPS at the very beginning, and HTTPS is a secure protocol that guarantees confidentiality, integrity, and authentication. So we definitely need to have HTTPS that protects the communication channel because we don't want our credentials to be disclosed to the man in the middle, right? That's why we have to make sure that HTTPS is used here. But now the question is like this: what's gonna happen when we change HTTPS to HTTP, right? So let's do it. Let's change HTTPS to HTTP and see what's gonna happen. And there are basically two scenarios. The one scenario is like this. You're gonna start with HTTP, example.com login PHP, and you will be redirected to HTTPS ://example.com login.php. This is really good because it shows that there is HTTPS enforcement implemented in the web application, right? So in other words, the web application does not allow you to go over HTTP to login functionality. It would be very risky because it would end up with disclosure of credentials, right? So the web application has to enforce HTTPS. And this is very nice. You try with HTTP and you are redirected to HTTPS. But when you try with HTTP and you are redirected to the same resource, so you start with HTTP and you are redirected to HTTP, then it basically means that you are still in the very same place. And obviously, HTTPS is not enforced. And this is very wrong because, well, when HTTPS is not enforced, then it actually means that your credentials will be disclosed over insecure HTTP, which is just plain text when you provide them and when you click login, right? So this is definitely wrong and you don't want it to happen. So you have to check whether this kind of problem happens in your web application or not. But even if you see that this kind of problem does not happen in login functionality, don't give up. And remember that hackers are smart. They will also check if disclosure of credentials via sign-up functionality is possible. Yes. When we talk about disclosure of credentials, well, you naturally think about login, but test login and after that, test sign-up. They are very similar. In both, you are providing email and password, and it may happen, I have seen it quite many times, that everything works very good for login, but in case of sign up, well, it just works differently. And in sign up, you've got the disclosure of credentials, and in a login, you don't have it. So this is what you have to also keep in mind, that you shouldn't limit your testing to login functionality only. You should also check sign up. Okay, now I believe that this is clear, and what I want to do is, well, I want to jump to the demo, and I want to show you how you can do this kind of checking of HTTPS enforcement in your own web application. So yeah, let's jump to the demo. Let me now play with the disclosure of credentials, and let me show you how to do a kind of testing here. So what you can see in the URL bar is https://example.com/login.php. So I'm going to provide my email and password, as you can see on the screen, and you see that this page is protected by HTTPS, which is secure protocol. So far, so good. So what I'm gonna do in terms of HTTPS enforcement testing is I'm going to change HTTPS to HTTP in the URL bar. So I will delete the S, right? Now I've got http://example.com/login.php and I will hit enter. Okay, what can I see right now? I still see https:// because there is HTTPS enforcement in the web application, and this is very good. So that, well, even if the attacker is gonna send you a link over HTTP, you will be redirected to HTTPS before providing the credentials, which is really cool, right? Okay, but as I told you, don't give up too early. Hackers are smart, and when we talk about disclosure of credentials, also look around at other functionalities like sign up. So let me right now go to sign up. What you can see, the sign up is also protected by HTTPS. You can see in the URL bar https://example.com/signup.php. The question is whether HTTPS enforcement also happens in signup. So what I'm gonna do right now is I'm gonna repeat the same simple step. I'm gonna delete the S here and see how the web application is gonna respond, right? So I've got http://example.com/signup.php and I will hit enter. Now, well, now I've got something surprising. I see just example.com/signup.php. I don't see HTTPS. When you don't see HTTPS, then it means that HTTP is used here. So now what has happened? I provided HTTP in the protocol part and I have been redirected to HTTP. So nothing has changed. I haven't been redirected to secure HTTPS. In other words, HTTPS is not enforced in sign-up functionality, and now you can clearly see it, right? Now what I'm gonna do, just to convince you even more, I'm gonna sign up and I'll put here some name, like Adam, for example, and the email, like for example, adam@example.com, and some password, right? I don't know, 12345678990, whatever. And I'm gonna intercept the traffic going out from my browser, and I will show you that indeed the traffic goes out over insecure HTTP. So what I've got here is a proxy. I'm using Burp Suite. Actually here, well, Burp Suite is an integrated tool for web application security testing, and one part of Burp Suite is a proxy functionality. Traffic from my browser is sent through this proxy, so I can actually see the requests that are sent out by my browser, right? Right now, I turned on the interceptor because I just want to intercept the request going out from my browser, okay? I hope it is clear. So now I'm gonna go back to my web application. I'm gonna click sign up. The traffic is sent through the proxy in my testing environment. The interceptor has been turned on, and here you see the request that has been sent out by my browser, right? It has been intercepted because I turned on the interceptor. And now what you can see here is, well, the name Adam, email is adam@example.com, password 123, and so on and so forth. But the most interesting part in the context of this case is here, http://example.com:80. It clearly shows that the traffic goes out over insecure HTTP, and HTTP is just plain text. So the credentials at the time of signing up are disclosed over insecure channel, and the man in the middle can now grab them, and voila, right? The end of the game, because the man in the middle has the credentials. Okay, I believe that this is clear for you, and now you see how powerful attacks can happen when HTTPS is not enforced in the web application. And remember, focus not only on login functionality but also on sign up functionality, because it may happen that the opportunity for you is out there. Okay, I believe that this is clear, so we can jump to the next subject. The next subject, insecure password change. I hope that you like the course so far and you will like it even more when we discuss the next bugs. So, a password change is very sensitive functionality, and we don't want any kind of weakness out there. We want this functionality to be really secure. And in this video, I'm gonna show you a kind of problem that I see quite often in different web applications. So let me present the story first. The user is logged in the web application, and the session ID of the user is ABC. Of course, this is for simplicity because session ID should be long and unpredictable, right? But this is just for understanding of the problem. Now, we've got also an attacker who got an access to a user's account. If the attacker was able somehow to get access to a user's account, well, then the attacker has his own session ID. For example, XYZ. Again, for simplicity, XYZ, right? Okay, so far so good. So we've got user and attacker. Now, user changes his password in the web application, and when the password is changed by the user, then the session ID equal XYZ should be invalidated, as it is then related to the user's old password. Now let me tell you more about this, why it is so important to do this, why it is so important to invalidate that session ID. Because we don't want the attacker to have an access to the user's account after the user's password has been changed, right? This is what we don't want to happen. And if we don't want it to happen, then we have to invalidate the session ID related to old user's password, right? So this is how it works. So what we've got here is a kind of intersection of password change functionality and session management. And now you can see in the story that when you don't do it securely, you will end up in problems. Because when this session ID equal XYZ is not invalidated, right, in our story, then the user is changing his password, but the attacker still has access to the account. So this is obviously wrong, and it shouldn't happen, right? So the lesson learned here is like this. When you do testing of password change functionality, you should think about session management as well. And well, the core of the problem that I'm discussing here is broken session management, and how broken session management can, lead to some problems, right? Like the attacker still having an access to the user account, despite the fact that user has changed his password. I believe that this is clear for you. So now let me jump to the demo and let me show you how you can check whether this problem happens in your application or not. Now in this demo, I'm gonna show you how to test for insecure password change in the context of broken session management. So this is gonna be exactly what I presented in the previous video, but now we've got a practical part, right? So as you remember from the previous video, we've got a legitimate user and we've got an attacker who was able to get access to the user's account somehow. We don't care how, right, in this kind of story. So I've got two browsers here. I've got Firefox, and let's assume that Firefox, this one, is the browser of the user. So you see that I am authenticated. And now I've got also Google Chrome, and so another browser. And let's assume that this is the browser of the attacker who was able to get access to the user's account, right? Now, what I'm going to do as a legitimate user, so I'm going to go back to Firefox, I'm going to change my password, right? So I'm going to click change password. And first I'm asked to enter the current password, so let me do it. And yeah, success. Now I need to provide a new password. And I will click change password. Okay, you clearly see here that my password has been changed. Success, password changed. This is my browser. And what I expect right now to happen is that the session ID related to my old password should be invalidated, right? So let me right now go to the attacker's browser and let me refresh this page. Let me refresh it. I'm gonna hit enter. I'm gonna hit enter again. I refreshed it twice and I still got an access to this account, right? To David's account. Remember, this is the attacker. So what's the conclusion? I changed the password, but the session ID related to old password, right, has not been invalidated. I changed the password in my account, but the session ID related to my old password has not been invalidated. And I can clearly see it here because I'm still logged in. I'm still logged in the attacker's browser, right? So it clearly presents the problem, right? If the session ID related to my old password was invalidated at the time of password change, then I wouldn't be able to get access to my account in the attacker's browser, right? This is it. Now you can clearly see that this problem exists and nothing has happened. The attacker who got access to the user's account can still have an access to user's account despite the fact that user's password has been changed, right? So this is how it works. I believe it is clear, so let me jump to the next bug. Okay guys, let me now discuss dictionary attack. And in order to do it, I will first start with a question. Can I guess a user's password without any limitations? That's the question, and the question is very much related to dictionary attack, because the dictionary attack is about guessing a user's password without any limitations. So we definitely don't want it to happen. We don't want the attacker to be able to guess our password without any limitation, right? Because if we allow the attacker to do it, then sooner or later the attacker will learn our password. And how the attacker is gonna do it? The attacker is gonna have a list of most popular passwords, and the attacker is gonna launch an automated attack so that there will be multiple login attempts with different combinations of email and password from the list, email and another password from the list, right? So we don't want it to happen. And one of the countermeasures that is used to prevent this attack from happening is implementing CAPTCHA. CAPTCHA is quite popular, and this is the exemplary CAPTCHA. So CAPTCHA is something that we humans, we can recognize the text here, the structure here, right? I, as a human, can say, well, this is RJCSN. But, well, I am a human. Now, humans are, able to recognize something like this. But when we talk about automated programs, then it's a real obstacle, a real challenge to figure out what is actually written here, right? And that's the reason why it is actually the countermeasure, right? Because it's an obstacle that prevents an automated program to do this kind of automated attack. Okay, so you see here a CAPTCHA, but it may happen that, dictionary attack is not possible and you are not using CAPTCHA. In other words, CAPTCHA is not the only countermeasure for a dictionary attack. So let me discuss another countermeasure, and it's gonna be, another question. Like, is the account blocked after 3, 5, or 10 unsuccessful login attempts? So now you can answer this question, how it works in your web application. If the account is blocked after, let's say, 5 unsuccessful login attempts, and you don't have CAPTCHA, then you've got a countermeasure for dictionary attack, right? Because if the threshold is 5, I mean the threshold of unsuccessful login attempts before the account is blocked, then, well, you don't allow the attacker to guess a user's password without any limitations. The limitation is 5 unsuccessful login attempts, right? So this kind of threshold, like 3, 5, or 10, on its own, it's still a countermeasure, and you don't need to have necessarily a CAPTCHA. And well, this threshold depends on the web application. In e-banking, it's gonna be very often 3 because this is very sensitive web application, right? And in case of less sensitive web applications, it will be like 5 or 10. Very rarely, this threshold will be greater than 10. So when you do like 12 or 15 unsuccessful login attempts for your account, and after 15 login attempts, unsuccessful login attempts, you are still able to log into your account, then very likely this kind of countermeasure is not implemented. I mean, there is no threshold that is used to block the automated programs that are trying to launch a dictionary attack, right? So this is how it works. So what you need to do as an ethical hacker, first check if there is a CAPTCHA, and if there is no CAPTCHA, just check if your account is blocked after, let's say, 12, 15, or 20 unsuccessful login attempts. If it is not, then you actually don't have a countermeasure, or you just don't see that there is a kind of countermeasure that prevents this kind of attack, and you can report the bug like this, and you can get your reward at the very end. So I hope that this is clear for you right now. So let me jump to the demo and let me show you how it works in practice. Okay, let me show you how to figure out whether a dictionary attack is possible in the web application or not. What I've got here is a login functionality, and what you see is that I am asked to provide an email and password. There is no CAPTCHA, right? There is no CAPTCHA. So what I need to do is try to figure out whether the account is blocked after, let's say, 12 or 15 unsuccessful login attempts. If it is not, then the great chances are that dictionary attack is possible, and you can report something like this right away to the program owner, right? So what I'm gonna do right now is I've got my own account, and well, I can play with my own account, right? So my account is like david@example.com, and right now I'm gonna provide some invalid password, right? Whatever, right? Whatever. And I see wrong email and or password. I'm gonna do it again for the second time. Arbitrary password again. And I see the same message, wrong email and or password. Now what I'm gonna do is I'm gonna repeat this kind of activity like 12, 13, 15 times and see if I can still do this kind of attack or not, or in other words, whether I'm blocked or not, whether I can get access to my account after 15 unsuccessful login attempts or not, right? So right now I'm gonna pause this video, and I'm going to do this additional 12 or 13 login attempts manually. Of course, I could do some kind of automation here, but there is no need. I can do it very quickly. So I'm gonna pause the video, and I'm going to come back to you after 2 minutes. Okay guys, I tried to log into my account 15 times with arbitrary passwords, and I have been unsuccessful all the time. Let me right now try to do it for the 16th time. Let's see. Again, the same message, wrong email and or password. And now the question is whether, well, I am blocked or not, right? Whether my account is blocked or not. I'll provide my email and my password, my real password, because I just want to see if I have been blocked or not in this 15 or 16 unsuccessful login attempts, right? So let me provide my real password right now. And what I can see is that, well, I am authenticated. So definitely I have not been blocked throughout this process of 15, let's say, unsuccessful login attempts. And it clearly shows that this kind of attack is possible. It clearly shows that dictionary attack is possible, and you can do it really quickly. You can figure out whether this kind of attack is possible or not. So I hope that everything is clear. It's time to summarize this course. So let me discuss the most important points. First, HackerOne. This is your big opportunity. You can go there and you can hack legally and get paid for your findings. There are great companies out there, so what you need is a knowledge and internet connection. This course is a follow-up of one of my previous courses, Start Hacking and Making Money Today at HackerOne. In that previous course, I introduced you to HackerOne, and I presented the list of 5 bugs that are really good to start with. So you have a kind of a starter. The list of 5 bugs for a start is good, but you need more bugs to be more successful and to be able to earn more money, right? That's why in this course, I focused on the next 5 bugs that really work, because I have been submitting them for years and I got paid for them many times. And I want you to double your payments, right? Because when you've got 5 bugs plus 5 bugs, so the more bugs you have, the more money you can earn, right? So this is the kind of thinking, and I want you to be successful with these bugs. So very briefly, what kind of bugs I discussed in this course. So I presented to you how you can impersonate a user via insecure login. And the problem that I discussed here was related to insecure session management and how insecure session management, or to be more precise, lack of session ID regeneration, can lead to user impersonation. Very nice bug. I see it quite often in web applications. Then I discussed something very strange at the first glance: sensitive information in metadata. You as an ethical hacker can find your opportunity in metadata. Metadata is out there in the documents that are hosted on the domain that is your target. Metadata is hidden, but it is out there. When you are able to extract this metadata, you can find interesting information, and this is exactly what I presented in the demo. Then I discussed the disclosure of credentials and how it can happen. I discussed HTTPS enforcement, how to test for HTTPS enforcement, and you also know that hackers are smart. They are not only focused on login functionality, they are also focused on sign-up functionality, because the opportunity is also out there. After that, I demonstrated insecure password change. And of course, we don't want any kind of weakness in this sensitive functionality. And you learned that the intersection of insecure session management and password change can lead to severe problems. And I present to you how the attacker can still have an access to the user's account when the user has changed his password, and this can be possible when the session is insecurely managed in the web application. And finally, I discussed the dictionary attack, so that you learned what this attack is all about, what kind of countermeasures are implemented, and how to test actually whether this kind of attack is possible or not. So I'm leaving you with the next 5 bugs that really work. And I keep my fingers crossed, because I want you to be successful as well. That's the reason why I created these courses. And yeah, I hope it has been informative for you. I wish you a good day, and keep hacking and making money at HackerOne. Bye bye.